Hello and welcome to part 2 of Unit 7, lesson number 3. This is range and quartiles. So our first lesson we did a sort of a review of mean, median, and mode as a way of leading into this discussion of quartiles. At the end of that first video we talked about what a quartile is, which is a calculation of the 1/4 and the 3/4 mark in a set of data called Q1 and Q3 respectively. Q2 is the median. We've already sort of been using that one with just a slightly different name. We're going to continue to call that one median, but just so you know, it would be the second sort of end of the second quartile, coming at halfway from the smallest to the largest value in the range. We did an example here. Now we're going to do another example that we worked through on our own. So if you remove the last data point, so I'm referring to that question that we had above where we had 7, 12, 15, etc., and we were able to calculate that out entirely. This happened to be one of those ones that had an odd number of terms. With an even number of terms, which would happen if we took 40 out of that first data set, how would this change how we find median, Q1, and Q3? Well, let's have a look at it. So as before, in trying to find the median, I am going to just start counting in towards the middle. So we've got 1, 2, 3, 4, 5, 6. And from the other direction, 1, 2, 3, 4, 5, and 6. So now our seventh term is sort of a combo, right? It's kind of that halfway one. So if we were going to be calculating the median here, the median is halfway between those two. So we do that calculation by adding them together, 27 plus 25, and then we divide it by 2 to figure that out. Of course, the answer is going to be 26, and that is our median. So I'll just sort of draw that in. That's going to be 26, and that is our median. So now that we have the median selected, interestingly enough, because the median isn't actually a point that we have included in our data set, when we're trying to find Q1 and Q3, we are actually we are going to include 25 and 27 in the same way that we didn't include them up top, because 27 was a point that we had. It fell smack dab in the middle. In this case, with an even number of points of data, we sort of had to make up our median, so to speak. So we are going to just count in. So as before, we'll do 1, 2, 3, and 1, 2, 3. So our fourth term there is halfway between our first data set, 7, and our median term, the imaginary 26. So our Q1 is going to be 17. And we're going to do the same thing for the back half of the data. So again, we are going to include 27 because that was not actually the median value. So 1, 2, 3, and 1, 2, 3. And here's our fourth value. That's going to be 33 for our Q3 term. So hopefully that makes sense. In these two examples here, we've now seen what if you have an odd number of points. Pretty straightforward. If you have an even number of points, we find the median the same way as before by adding the two middleist terms together and dividing by 2. And then doing that same counting that we did from the middle to the beginning and finding halfway, and from the middle to the end and finding halfway to get the Q1 and Q3 points respectively. Hopefully that makes sense. Let's take a little bit of a step further forward, and we're going to be looking at the interquartile range. So the interquartile range is basically finding where the middle half of the data is happening. So it removes everything below Q1 and everything above Q3. So if you can imagine that visually here, if we're just talking about this data, I'll just grab sort of the pink here. So really it's just trying to help us find like this chunk right here, which represents the middle half of the data. If you consider that half your data is found here, and the other half of your data is found here, that doesn't make sense. Rather, the first part here, which represents the lowest quarter and the highest quarter, combined, they make a half of your data. And then you've got the rest of it kind of in this middle. So interquartile range is this stuff right here in the middle. So how do we calculate that? We calculate that by finding the difference. And again, difference, if we're talking about it, is subtraction, as you can see here. So we're trying to find the difference between Q3 and Q1 in order to identify the interquartile range. So basically between Q1 and Q3, how many points are we talking about? That's what we're looking to find. So let's do an example that takes us right from the beginning to the end. So here's some data that shows science scores. We have 91, 90, etc. So we're going to write this data from smallest to largest. So let's do that now. I'll do that in blue. So let's see, lowest value here looks like 50, I guess. There's 50, and then we have a 55, and a 57, and then we have a 66, and then we have a 72, a 75, a 79, two 81s, and an 82, an 88, a 90, and a 91. I think that's all of them. All right, so there is us rewriting our data from smallest to largest. That just makes it easier for us to do other calculations moving forward. So let's circle, or if we need to, calculate the mean. So let's count our way in and see how we did here. So let's do 1, 2, 3, 4, and 5, and then 1, 2, 3, 4, and 5. Okay, we didn't quite make it to the middle, so that's 6 and 6, meaning that our 7th term, our median, is going to be 79. So median is 79. That's our middle term. So we're going to now calculate Q1 and Q3. So Q1 is going to be halfway between our first term and our median, our middle term. So let's start counting those in now. Now, because we've included 79, it's actually a point of data this time. We are going to not include it. So that's 1, 2, 1, 2. What you'll notice is we've got sort of a tie here for Q1. So as we do when we have this happen in the median, we are going to add those two values together and divide by 2. So 66 plus 57, and we're going to divide it by 2. Let's add those up. So 66 plus 57 gives us 123. And we're going to divide that by 2, so then Q1 will equal 61.5. So that is going to be our Q1. And let's do Q3 now. So Q3, same thing, because 79 was in our list, we're going to not include it, so that's 1, 2, 3, 1, 2, 3. So once again, we've got sort of a tie here for what our Q3 is going to be. We're going to find the average there. So we've got 88 plus 82. We're going to divide that, by 2. So 88 plus 82 is 170, which we're going to divide by 2 to get a Q3 value of 85. So those are our Q1 and Q3 values. So here we have 85, that's Q3, and 61.5. Not really any room here, we'll put it up top, I guess. 61.5 for Q1. Bit of a mess, but there it is. So now, the interquartile range, which we just talked about, is the difference between Q3 and Q1. So we're trying to find that middle half of the data that falls in the middle of our entire range. So in order to do that, we take our Q3, which is 85, and we subtract our Q1, which is 61.5, and that will tell us our interquartile range. So 85 minus 61.5 gives us 23.5. Whoops, 23.5 for our interquartile range. So that's how we work it through. Again, just to recap that, we do a rewrite to get all the terms in the right ascending order from smallest to largest. Find your median. From the median, you find Q1 and Q3. To find the interquartile range, you subtract Q1 from Q3. So we're going to do this whole mess over again. Here's our data. There's our stuff. So we are going to look at another set of data from another class. Same idea. So we're going to start by writing this data out from smallest to largest. So let's jump in there. So looking at our grouping here, the lowest this time is 24. And then we have a 50 again. And then a 55. And a 57. And a 66. And a 72, a 75, a 79, two 81s, 82, a 97, and a 100. I think we got them all there. Okie doke. So there we go, data from smallest to largest. So now we're going to find the median. So the median, of course, is the middle value. Let's count our way in. 1, 2, 3, 4, 5, 6, I think. So it got us there last time. 1, 2, 3, 4, 5, 6. And there is our 7. So there's our median value right there. So median is 75. Is 75, which I think is the same. Oh, not quite the same as last time. Now we're going to calculate our Q1 and our Q3. So again, because 75 showed up in our actual data points, we're not going to include that. So that's 1, 2, 3, and 1, 2, 3. So here again, we have sort of a combo. For Q1, we are going to take 57 and 55, add them together and divide by 2, which is going to give us 56. And we're going to do the same thing to calculate Q3. So that's 1, 2, and 3, and 1, 2, and 3. So again, we've got sort of a combo here. We need to combine those two terms and find their average. So that's 82 plus 81 divided by 2 gives us 81.5 as our Q3. I did the math a little more quickly that time. Hopefully that's all right. And now to find the interquartile range, I take the highest point I have of the two, so that's my 81.5, that's my Q3, and I'm going to subtract my Q1, which is 56. So we have 81.5 minus our 56 gives us, just squeeze it in there, 25.5 is our interquartile range. So again, what the last question here on this page is, what does the IQR show us when we compare it to the class in the previous question? So if we look at that, 25.5 versus 23.5, there's not a significant difference there. There is a difference insofar as the middle sort of grouping of values is smaller in our first class than in our second class. So if we look at the first class, just generally, our lowest point is 50, and what I'm referring to is just up here. Our lowest point in the first class's data set was 50, and the highest one was 91. So we can see that objectively, that's just like 41 range, right? So that middle bit will be smaller than in our second class, which has a significantly larger range, right? We went all the way from 24 to 100, which is 76. So from whatever it was, 41 to 76, like it's a much larger spread of data, which is reflected in the IQR. So when we compare it to the two classes, a sort of a larger IQR typically indicates a larger spread in the whole data set. So we're going to go on, do some more examples, but here is an excellent spot to stop this video. So I'll see you guys in part 3.